All right, so one of the things you're now all masters of the stress strain curve, uniaxial stress, complex stress states, but we haven't talked about one important thing, which is if you have complex stress states, how do you actually run these experiments? How do you actually figure this out? How do you measure these things? Well, in reality, one of the things that we do is we can actually rotate stress states. So we are actually going to apply some certain stress, rotate our coordinate system, and then you can figure out, well, where are stresses, for example, if I'm looking at this system here, what's the stress at some arbitrary angle here? Or if I have, a bridge and I have trusses and I have all these kind of complex, geometries, and I'm applying a system like this, what's the stress, at this particular angle, right? What's the stress on this component here? Well, that's where stress transformations come into play. And this will be very, very important when it comes into trying to figure out, and what we're going to really try to figure out is, what are the rotations that lead to a normal or principal stress state? A principal stress state means I only have normal stresses. I could also have stress states where I have maximum shear stresses, so when the shear stress is maximized. So I can figure out rotations where this will occur, and this is very important because ceramic materials typically fail where normal stress is maximized. Metals typically fail where shear stress is maximized. So we have to figure out what this rotation is. So, first way we can do it, I call it the geometry and plug and chug mechanism. We know we have to be at static equilibrium. So if I have the following stress state like this, if I want to find the stresses at some new coordinate system in some new angle, you see the primes here are going to indicate our angle, I could do a whole bunch of geometry, I could look at some of the forces equal to 0, and I could find this huge equation to figure out what's my new stress in the new XX and the YY, or the 1,1 and the basically 1,2,2, and then what's the new basically shear stress in these arbitrary locations. So we can do that. We could also figure out what's the angle that is going to find or give me my maximum or my principal stress state, and what are the values of those principal normal stresses, where sigma 1 is always going to be greater than sigma 2. You can do the same thing for maximum stress, shear stresses here. So my question is, can you do this on a job interview? Or are you going to be able to always memorize this equation? And then this is a very simple, it's not general, this is for a 2D stress state here. And most importantly, if we put numbers to this stress state like here, could you find what's the stress state at a 15 degrees clockwise rotation around the 3-axis? What's the principal stress state values? What's the angle to get to this? Can you do this easily? So our first method is going to be the plug and chug geometry approach. So I would say, after many years of teaching this class, if you have this stress state here, which is a plane stress state, I only have stress in the 1-2 plane, as you can see here. If I do the plug and chug method, this would be my value of sigma 1, my maximum normal stress. This would be my sigma 2, my next largest normal stress value. This is my maximum shear stress, right here. This would be the angle, 19.3 degrees, to rotate to get to my maximum, my principal stress state, 19.3 degrees counterclockwise. If I want to find the stress rate at a 15 degrees clockwise rotation, that's negative, I could plug in the angle, and this would be my stress state here. Does this tell me what's the angle to get to maximum shear stress, like right here? No. This method is not robust, it's not intuitive, it's susceptible to so much error, as you can see with all these equations. This is not the way that we want to go about solving the problem. So I'm going to show you two different methods. One is Mohr circle approach, which is a very, very useful approach to answer certain questions that you want about the system. And then I'm going to show you a linear algebra approach, which I believe is the preferred approach, the best approach, and the one that you will utilize most often in your career. So I wanted to show you this because we're going to get the same answer in 3 different techniques, but never do the plug and chug method, please. If anything else, that's all I want you to take away from this lecture. All right, so next time, Mohr circle, and we'll see it's a much, much better approach. See you next time.